Hi there, welcome to your flip video for lesson 3.2, rate of change and slope. I'm Coach Friday and I am excited to be able to teach you about these two awesome things that are really in algebra, but as 8th graders you guys absolutely need to know. So the text that we're going to be looking at today are 8.4, which says use data from a table or graph to determine the rate of change or slope, and y-intercept in mathematical and real-world problems. And we're also looking at the process standard, that's 8.1f, which is analyze mathematical relationships to connect and communicate mathematical ideas. Okay, looking back at our standard of 8.4, we are definitely going to look at data from a table or graph, okay, to determine the rate of change or slope for this lesson. We're going to get into this y-intercept next week into Module 4. Okay, so if you look in your book, our notes from the book, if you want to go back and refer back to examples, are on page 65. On that page, okay, the question for lesson 3.2, our essential question is, how do you find a rate of change or a slope? So we're going to start with that today. So if you have your notes, your fill-in-the-blank notes, you should already be doing that. But if I'm looking at the definition of rate of change, which is also on page 65, okay, we are actually going to be looking at the rate of change is a ratio, and I know you guys know what ratio is. Okay, ratio can be written in a couple ways. Okay, it could be written as a fraction, so A over B. It could be A and B, or it could be A out of B. Those are three separate ways of writing a ratio. Today we're going to look at how it's written as a fraction. So the rate of change is a ratio and the amount of change in the output, which really just means our y values, to the amount of change in our input, which are x values. So if I look at this definition, it's really talking about the ratio, which is a fraction, and I can do the change in y values divided by the change in x values. Okay, so really that's what the rate of change is. Now, when a rate of change is the same between all the points, the rate of change are constant. And we sort of talked about that in lesson 3.1. Okay, and constant just means that it stays the same. So if I go back in my notes and look on page 65 at that first example, okay, I'm noticing that in this first example, I have 4 different days. That x represents the number of lawns and y represents the amount earned. Okay, so first of all, if I needed to find the rate of change between the 2 days, I'm going to start by looking at day 1 and day 2. Okay, notice the change in money first, the change in our y values. 45 to 15. To find that change, I'm going to subtract the 2. So 45 minus 15, which will give me 30. Okay, and then I have the change in the days. So from day 2 to day 1, I had 3 to 1. So 3 minus 1, which is 2. So when I simplify that, 30 over 2, I'm going to get 15 for my rate of change. I could look at day 2 and day 3 and notice that based on those days with the amount earned and number of lawns, I'm still going to end up with a fraction that is equivalent to 15 over 1, or giving me a ratio of 15 over 1. So my rate of change again is 15. That's one way of solving it. So after looking at example 1, we noticed that the rate of change was constant. Between the points it was 15, so we have that rate of change. Now sometimes between points they're going to be different, and when the rate of change is different between the points, okay, the rates are variable. Okay, which means that the quantity can change. Now, this looks very familiar to what you guys learned in 3.1, and that was to find that rate of change. Okay, we can also use the formula from 3.1, k is equal to y over x, which is our constant of variation. Okay, we can look at the bottom of page 65 at this example that says your turn. Okay, the table shows the approximate height of football after it's kicked. So our x values represent time, and then our y values represent the height of the football. So if I'm using that formula, k is equal to y over x, okay, I'm going to take 18 over 0.5, plug that into my calculator, and it comes out to be 36. So the rate of change there, or the constant, is 36. Now if I look at another point that was given to me, I'm going to do the same thing. Y over x is equal to k. Plug in my numbers. My y value is 31. My x value is 1.5. If I plug that into my calculator, I get 20 and 2/3. Okay, notice the constants are different, which means that we don't have a constant rate of change here. We have a variable because our rate of changes are different between the points. So that's one way of recognizing the rate of change from points on the table. Now another way that you're going to have to be able to identify, again from our TEK that describes that we have to use a graph or a table to determine the rate of change, is we're going to be given the table or an actual line on a graph that we have to use to figure out what that rate of change or slope is. So what we're going to do is we're going to use the formula y2 minus y1 all over x2 minus x1. When I say all over, that means that we're dividing. And what this means is from our definition of rate of change, okay, in other words, the slope is the change in our y values over the change in our x values. So when I'm looking at something, a question like this that STAR might ask, page 66 has a really good example. Okay, it's giving you a graph, and we want to figure out Nathan's rate of change because this is how much he's bicycling over time. So what I can do is I can pick 2 points. Let's say 2:30 and 1:15. That means in 1 hour he's ridden 15 miles, and in 2 hours he rode 30 miles. So what I'm going to do is I'm going to use these 2 points with my formula. Okay, my formula again is y2 minus y1 over x2 minus x1. Okay, if I label these points sort of what we talked about today in class, I have point 230 and I have point 115. Okay, so if I look, this is my x value, my y value, x and y. I'm going to identify which one's first. Well, if this is my first point, 1 and 15, this is going to be my x1, y1, x2, y2. First point, that's xy. Second point, that's xy. That's where I come up with that. Now, if I plug in this information into our formula that was given, okay, my y2 is going to be 30, and then minus my y1, which is 15, all over x2, which is 2, minus x1, which is 1. Now, just like a fraction bar, I want to simplify the numerator and simplify the denominator and then divide. So 30 minus 15 I know is 15. 2 minus 1 is going to be 1. And that fraction, or that ratio, is simplified. So my rate of change between those 2 points is 15. So using that formula, if I look at the steps that I gave to you, to find the slope of the line given 2 points, these are the steps we need to take. We need to subtract y value 1 from another y value 2. So again, that's y2 minus y1. And then we subtract x1 from another x2, so x2 minus x1. Remember, when we subtract a negative, that means that we are adding when there's 2 negatives next to each other. So if I'm looking at this example right here, okay, I'm first going to identify my x1, y1, x2, y2. In this first point, here's my first x and my first y. And here's my second x and my second y. When I plug this into my formula, I'm going to rewrite my formula just so it gets stuck in my brain. y2 is 3 minus y1, which is 7, all over x2 is negative 2, x1 is minus 1. So when I simplify this, 3 minus 7 is negative 4, and negative 2 minus 1, keep it, change it, is going to be negative 3. From there, my two negatives ends up being a positive, so my answer here, I'm going to keep it in fraction form, is 4/3. So that's another way. This would be our constant, or our rate of change here between these 2 points. This is the rate of change. So another name for rate of change is actually going to be the slope of a line. And it sounds just like a mountain, a slope. We're either going up or we're going down the slope. When the rate of change is constant, every part of the segment is going to form that straight line. Vertical, it's going to be a straight line. So just know that the rate of change, when it's constant, is the same thing as a slope. Okay? And what the definition of slope is it's the slope of a line is the ratio of the change in our y values, just like our definition of rate of change, to the change in our x values. Now if you think of y values on a coordinate grid would be the vertical line. So those are going to go up and down. We're going to call those the rise. You can either go up or down. Okay, our x values represent going side to side. That's going to be considered run. So what this means, if we're looking at the ratio of our change in y values, which is our rise, the ratio would be rise over run. And that's exactly what our equation is to figure out the slope from a line on the graph. Okay, another thing that the slope determines is the steepness. We're going to go into this a little bit more later on, but the larger the number, the steeper the slope. So go ahead and take a second to circle the line of the bigger slope. There's 4 different types of slope. If you look at this graph going from left to right, I'm looking at this line and looking at the slope. Left to right, it's going up. So this is going to be a positive slope. If I look at this graph, my line is going from left to right, it's going down, which means this is a negative slope. Now these last two, a lot of kids get mixed up. Okay, this line that's running along the x-axis, okay, is actually a horizontal line. Now the way that I remember what type of slope this is, I look at that z in horizontal. This is a 0 slope. Okay, and then this line right here, and we'll go more in depth of this tomorrow in class, this line is going vertical, up and down. The way that I remember this is that V looks a lot like a U, which means it's undefined. So those are 4 different types of slopes: positive, negative, 0, and undefined. Okay, now we need to figure out from this graph how we can actually find that slope or the rate of change. Remember that it's the same thing. So when given a graph with a line, just like we are here, we need to do a simple equation, which was rise over run. So if you look right here, here's a diagram. Our rise again is going up or down. In this case, it's going up from this left point. Okay, and then it's running to the right to this next point. So I'm going up and to the right. So the way that we have to do this, the problem is going to give you a graph with a line with 2 points, or sometimes you might have to put points. And when you do have to do that, make sure your points intersect the grid perfectly. So in this case, I have my 2 points, and I'm going to start with the one furthest to the left. Okay, if you notice, go ahead and plot that point and tell me what that ordered pair is for both points. Once you plotted those points, you should have gotten -2, 1 for the point that's furthest left, and 3, 3 for the point that's furthest right. Okay, so if I'm looking at the point that's furthest left, okay, I'm going to find the rise first, which means if I'm going up, those are going to be my positive numbers. If I'm going down, it's negative numbers. So from here, I'm going up 2. So plus 2 is my rise. So if I write it off to the side, rise over run, I have plus 2 for my rise. From this point right here, I have to do my run. So I'm going to the right, which means I'm going positive numbers. If it was to the left, it would be negative. So from this point, I already went up 2, and I'm going over 1 unit, 2 units, 3 units, 4 units, 5 units. So that means that the run is plus 5. Now I want to keep it in our fraction form for our slope. So my slope is going to be 2/5. Okay, go ahead and do the practice finding the slope from a graph with 2 points already listed for you. And then also finding the slope between just 2 points that were given from the table. Finish these 4 questions for homework, and this will be your ticket into the classroom when you arrive the next day for class. I hope you enjoyed my video, and if you have any questions, make sure that you are asking during class so we can help you with this concept. Have a great night.